I still keep learning from the incidents, and I will actually demonstrate that from the incidents that I was involved in later on, okay? Oxidation reduction reactions, it involves a change in oxidation state. Reminder, the oxidation state of free elements is 0, and some elements may exhibit more than 2 oxidation states, 0 and something, 0 and the negative ion or cation or anion, okay? Now, ever since high school, this is the acronym that it's got stuck in my mind, and this is what my chemistry teacher told me. You have to remember this just in case you come across reduction oxidation reactions, redox. GEROA. It stands for gain electron reduced oxidizing agent. That means the oxidizing agent or the oxidizer, you know, oxygen, chlorine, any of the halogen families, gains electrons, you see, GE, gains electrons, and is therefore reduced. That means the charge decreases. You see oxygen? Oxygen, the free oxygen has a 0 charge, but then when it's reduced, it becomes -2. 0 to -2, reduction in the charge. 0 to -2, 0 minus 2, right? So I always keep that in mind just to, but you know, sometimes there's like a semester or like 6 units of just balancing equations. You don't need that as CUPA inspectors, okay? But just to understand what is the oxidizing agent and what is the reducing agent, this will give you an idea. The oxidizing agent gains electrons, so that's why it becomes negative charge, okay? Or decreased charge. I mean, it could also be something different. Depends on the equation. Nonmetals usually act as oxidizers, like oxygen, chlorine, fluorine, iodine. Those are oxidizers. Metals act as reducing agents. Group 1 metals react violently when oxidized. Group 1 metals are what? Lithium, sodium, rubidium. Activity series of elements. This is also nice to know as CUPA inspectors, so you know which elements can release hydrogen from water. Look, elements, keep this in mind. Cesium, lithium, rubidium, potassium, barium, sodium, calcium, magnesium. It releases hydrogen from water. That means you don't add water to these metals, okay? Or else, boom. And you know, it's nice to have experience because I actually experienced sodium and water in the lab. And it just really makes a loud boom, okay? And it was just like a pinch, like less than a pea size, and it just made a loud boom inside the chemistry lab. It was not my fault, though. Somebody else's, okay? Elements which release hydrogen from acids. Aluminum, manganese, zinc, chromium, iron, nickel, tin, lead. You don't have to memorize any of this, but just be familiar that some of these metals can release hydrogen, especially from water. At least you need to know sodium, you need to know calcium, lithium, magnesium. Those are common materials that you encounter as CUPA inspectors. Elements which do not release hydrogen from acids, these are, you know, not very reactive, not very electronegative elements. Bismuth, copper, mercury, silver, platinum, gold. A special type of redox reaction is combustion. Fire department, right? Combustion. Slow versus rapid. Rapid combustion releases large amounts of heat and light energy, resulting in fire. In addition, gases may also be evolved. Sudden evolution of gases creates excessive pressure, therefore gives you a loud bang. What is a slow combustion? Slow combustion takes place at low temperatures. It occurs at molecular level. Cellular respiration is an example. I actually have another example in one of my cases. Complete versus incomplete. In complete combustion, all the elements in the fuel yield the most common oxides. The most common oxides being carbon dioxide, sulfur dioxide, nitrogen dioxide, and water. Okay? But then, there's also such a thing as incomplete combustion. Incomplete combustion occurs when there isn't enough oxygen to allow the fuel to react completely. Or actually, not just oxygen, some oxidizing agent. Okay? The products of combustion may include carbon monoxide, unburned carbon or soot, and lower hydrocarbons. Now, I don't know if you can already tell that I have a passion for chemistry. But I also have inspiration. My kids, Isabel and Jay. That's my inspiration. But please, don't tell my wife that I used the kids' pictures and I did not use hers. Please, if you meet her, please don't say anything. But I know that this is, oh, he went off topic. He put pictures of my kids, of his kids. You might put it in the evaluation. I can take it, okay? I can take it. But we go to the more interesting part of the session. I told you before, I don't know if you can tell, I am good in chemistry and I have a passion for chemistry. But I come across incidents, because I'm a part of the emergency response group of Los Angeles County. I mean, I used to be a CalARP inspector. I used to be a hazardous waste inspector. And then I moved on to emergency response because there's more money. But can you please delete that? Anyway, the first incident that we're going to cover is a hydrogen peroxide spill. Second, aluminum powder. Third, anhydrous ammonia release. And spontaneous combustion. See? Now, to those of you who are privy to our Hazmat newsletters, I mean, I already discussed some of these incidents in the newsletter. So if you read those already, you may leave the room. Anyhow, sorry. Okay, let's start off with hydrogen peroxide. Okay, picture this, okay? There's a delivery truck. There's a delivery truck with drums and drums of stuff. Drums and drums of stuff. He was traveling the 710 freeway, southbound. I remember it's southbound because the 60 was also heavy in traffic because of that incident. So the truck driver was traveling southbound on 710 on the 710 freeway, and other drivers saw his truck steaming. I mean, there's smoke coming out of it. So they just honked at him and then told him, there's something wrong with your truck. So he actually pulled over and tried to see what's going on the back of his truck. And so, of course, he called his dispatcher. The dispatcher called the CHP, and so on and so forth. So, in effect, the freeway was closed. The entire 710 southbound was closed because they looked at the shipping manifest and they checked which possible chemicals could have done this. I mean, he was delivering some electronics equipment, maybe some iPods. Too bad they did not get contaminated. If they did, then I needed one. Anyway, so smoke coming out of the delivery truck, right? Then looking at the shipping manifest, they saw that he was delivering drums of hydrogen peroxide, 50%. 50% is actually concentrated hydrogen peroxide. I don't know if it's a regulated substance. Before, it used to be regulated substance if it's 52%. Now this one is 50%, but even so, it's still very, very strong oxidizer. It spilled from the drum and reacted with the wooden flooring of the truck. The wooden flooring, of course, is organic. It's got carbon and so on and so forth, other things. So the freeway was closed, I said. The leaking drum was behind other items for delivery. Okay? And there's smoke. So the freeway was closed. And of course, you know, if the freeway is closed, and this is LA, right? So CHP wants it open as soon as possible. I mean, no matter what you do, you have to do everything you can to make sure that you open the freeway right away, right? So we're under time pressure. We're under pressure by CHP that, hey, you have to do something about this. So hazmat squads, you know, the hazmat squads, the ones from the fire department. Well, we were there just because we're hazardous waste, we're technical reference, and so on and so forth. So what is the challenge? Well, you see, the thing is, in order to get behind the electronics equipment, you have to use a forklift, right? And using a forklift on a freeway scenario, the initial entry team was asking, do we really need Level A. You know what level A is, right? Fully encapsulating suits. You're going to drive a forklift in level A and try to remove the front pallets and then get to the other pallets inside? Well, the challenge is it level A or level B? Now, what is the difference between level A and level B? Gary. Close, but wrong. Level A is fully encapsulating suit. Both level A and level B are actually SCBA, with SCBA, okay? So respiratory protection is already guaranteed for level A and level B. Level A is fully encapsulating to provide protection against corrosive vapors or corrosive gases, okay? Corrosive vapors or corrosive gases. Corrosive gases are chlorine, ammonia, meaning if it just gets on your skin, it burns you. The problem is hydrogen peroxide is also corrosive. It is corrosive, but hydrogen peroxide easily decomposes into water and oxygen. That's why there's a lot of like steam coloring inside the truck, right? It's just steam. So the hazmat squad was asking me, well, why do we have to do level A? I mean, they would do it if it were not for the forklift, you know, because the forklift, you know, because you have to drive the forklift and then the SCBA is here and then it's fully encapsulated. It's way too meticulous, right? So they were trying to convince me, let us go in level B. Let us go in level B. So the challenge is, you see, in my mind, I mean, and again, the pressure of CHP is right there over my head saying, oh, you have to do something, you have to do something. So what do? Do you say to the hazmat squad, go ahead, level B, because it's just water and oxygen. It's steam. It's steam coming out of the reaction from the wood. But no. Hydrogen peroxide can remain as peroxide in the vapor state. You got it. Hydrogen peroxide can remain as peroxide in the vapor state. You see, the problem with chemistry is that, you know, there are some chemical equations and you can balance them, right? And then chemical equations are dependent on the pressure and the temperature. The problem is, in this truck, we don't have any control over any of this. We don't have control of pressure. We don't have control of temperature. We don't know how hot it is there. Even if you have your, what do you call this, infrared kind of thermometer kind of thing, it doesn't give you the exact readings and at different areas of the truck. It may be hotter, it may be colder. So there's no control over that. So I have to make the decision. It has to be level A. Because if you go in and there's still hydrogen peroxide in the vapor state inside the truck, then it will burn your skin. Because fully encapsulated level A will protect you from corrosive vapors. Of course, the forklift was used to locate the leaking drum. We located the leaking drum, and that was the main challenge. Overpack, leaking drum, and then the truck vented. And then the freeway was, of course, open. Happy ending. But this one was very challenging because of the time pressure, and it is one of those rare times, very few times, that the hazmat squad was actually kind of like asking us questions on whether to do level A or level B. Most of the time, hazmat squads are conservative. They want to do level A. They go level A, no matter what, anyway. But this is one of those things that, you know, since we're going to be using a forklift, how do you, and we want to open the freeway and so on and so forth. So that's why, you see, that is the reason why, even if I know chemistry, it's still a challenge. You still learn a few things here and there. Yes, ma'am? You have a question? Of course. That's why the freeway was closed. Yeah, we have zones were established. Yes. Oh, no. Oh, I think everybody heard, right? The question was, did you have to establish zones? The answer was yes. Aluminum powder. Oh, my favorite. My favorite incident. Okay, picture this. And you can easily picture this because it's because of the economy. There's a foreclosed home in Lancaster. There are thousands of them, okay? But there's one foreclosed home in Lancaster. The bank was trying to clean up the house, right? They asked a young guy, younger than Gary. He was younger. Like he's like early 20s. You're not early 20s, are you? Oh, okay. He said close. Anyhow, so the early 20s guy was cleaning up, and then he happened to see this one in the back garage, okay? And he saw it. It says, it's not clear, but it says danger. Danger, explosion hazard, contains finely divided atomized aluminum powder. And it says, at the bottom, or somewhere here, it says, keep away from heat, water, and sparks. Okay? So he immediately called of course, his boss. And then the boss called the sheriffs. And of course, the sheriffs called us. But since it's Lancaster, it takes us like 5 hours to get there. So, no, I'm just kidding. Just 2 hours, actually. Sometimes 1.5, depending on the traffic. Anyhow, the sheriff's patrol guy also called the bomb squad because it's explosive. You see, when it's explosive, when there's a danger, explosion hazard, it's like protocol for the sheriff's patrol guy to call on the bomb squad as well. So, naturally, we were behind the bomb squad because of traffic. Let's put it at that, okay? So the sheriff's bomb squad was already there. So, anybody from law enforcement here? Please, before I make fun of them. No? Okay. No, I'm not going to make fun of them. I have utmost respect for law enforcement. Actually, really, no, truly. So the bomb squad was there before us. And they saw this. And they evacuated like half a block. Okay, they evacuated half a block. And then they said, they told the people that there's an explosion hazard and this and that. It can easily be triggered, so everybody keep away, and so on and so forth, right? So it's a big hoopla, right? Now, so when we arrived, we were briefed and so on and so forth. I know about the activity series of elements. Have you seen that? Remember activity series of elements? In there, the group 1, just so you know, aluminum is group 3, okay, in the periodic table, okay? Group 1 and group 2 can react with water instantly. Sodium, magnesium, lithium. But aluminum is not part of that, right? It's not part of that. But the challenge is, it says finely divided. That's the challenge. Finely divided aluminum powder. Container clearly marked, keep away from water. And then the literature on aluminum powder, it's explosive dust formation is possible. Okay, explosive dust formation possible. Water reactive, producing hydrogen gas, because it is finely divided. Okay, it's not because of the activity series of elements, wherein it says actually aluminum can remove hydrogen from acids, but not from water. But in this case, because it's finely divided, it can, because it's finely divided, all right? It has something to do with the surface area and so on and so forth, but much too detailed for chemistry there. But all you need to know is that it is water reactive, it produces hydrogen gas, and of course, bomb squad was on scene with Hazmat. What do you do with that container of aluminum, 30-pound container of aluminum powder? Okay, so I know from my background that it's not as reactive as sodium, but it is finely divided. So the challenge is, what do we do with the aluminum powder? How to handle and dispose of the aluminum powder? That is the challenge. How did we resolve it? To avoid dust formation, you need to stabilize the powder. Remember, it says there in the MSDS and online, we go online now when we go to incidents. Good for LA. Yes. we need to stabilize the powder so that it doesn't create dust explosion hazard, right? To stabilize, the question is, what is the most common solvent that we can use, like right there locally, to stabilize it so that it doesn't create powder? I'm sorry, it doesn't create dust formation, right? So the choice is between water and cooking oil, because cooking oil is readily available from the crowds. Actually, they were like volunteering already to give us cooking oil. None of them were olive oil still, though. So, it's not. Or to leave it as is. Leave it as is. Those are the choices that you have. You can stabilize it to avoid dust formation, and you can stabilize it by using water or cooking oil.